Hi everyone, welcome to APAC AI. And today it's going to be very special because this is the first anniversary of APAC AI. And let me quickly share my screen. Allow. Wrong screen. I'll just do it right like here. Just give me a second. Primary. Yeah, this monitor. So yeah, we anyone who has been with us for a while, they might actually know that we started as Brisbane AI, and now we started as Zoom community, and now we are on StreamYard. We have renamed ourselves to be APAC AI, so that we can cover a more broader audience, not just Brisbane and Australia. And in 2020, we ended up with 300 members, and it's not even half of the year over, and we already reached 500 members. So we are getting more and more people, and hopefully you're enjoying the content we are giving to you, and that the next 1 year is going to be even more awesome. Now, if you want to join us on LinkedIn, Meetup, or even if you're interested submitting your own talk, you can go to GitHub and follow us on Twitter. And today we're going to start with some news. Saraf is going to give us some interesting updates. Then we're going to go to Marco, who is going to talk about ML.NET. And at the end, we're going to have Q&A. So please send all of the questions on the YouTube comments. All right, Saraf, let's add you to the stream. Are there any good news?
Hey, good evening, everybody. Like Jake has said, welcome to our stream. We're happy to celebrate our 1-year anniversary with you. In terms of news, there's a few that I've found that looks interesting. The first one is a study by MIT that was done, which talks about the new wave of robotic automation. The link, which is on the slide, if you want to have a quick read through it, please feel free. Basically, all it boils down to is there's a new company called Real Time Robotics, which is headed by Peter Howard, which is a startup company, and they're doing autonomous robot motion planning. So I found it a very, very interesting read to see where AI can lead to in the future. AI and robotics can lead to in the future.
Okay. Yeah, we can read this after the user group.
The second one is the enterprise opportunities with 5G. Edge computes in the cloud. It's kind of related again to real-time AI. So Microsoft are putting in a lot of resources in unlocking the power of 5G, IoT, and real-time AI services to put up new solutions. And from what I've been reading, the multi-edge cloud, which this is a part of, is going to grow exponentially within the next few years.
Awesome.
And there's a few other use cases as well. Please feel free to have a look at that link. The ban and restriction on AI is something that was left behind from a previous presentation, and I'm sorry about that. Okay. The next one is quite interesting. Next one is from Google. It's called Explainable AI. So what that boils down to is a few things. So at the moment, when you create a AI model or a machine learning model, it is a difficult proposition to take it from text speak, which we are quite used to, and explain it away to the business. Okay, Google have come up with a comprehensive set of tools and frameworks that can be used to do this. And the benefits of doing this is basically increasing the trust in your AI models and increasing your business's trust in the AI models, helping you troubleshoot a lot better, and finding out if there are any biases or anything else like that you need to figure out before you go live to production.
Awesome. I don't think we have that slide. I have here the Amazon Health link. So maybe send the link to that news on the YouTube.
Yeah, I'll add that in. Just give me a second.
All right. So those are interesting news. And we are going to go to the main person for tonight. Hi, Marco.
Hi, how are you?
Great. So you are from Italy. It's morning at your time.
Yes, it's 9:30. 9:30 a.m. and well, good anniversary, Apac AI.
Thank you. And thanks for taking time off from work so that you can speak at our event. And I'm really, really interesting what you have to say. Like, I really love ML.NET. I actually have, I don't think it's not visible.
It's not visible in this image. Okay,
You
okay.
can see here that I love ML.NET. So I'm very excited for this talk. And can you tell a little bit where you work and what do you do before we get started?
Yes, I'm, well, my name is Marco Zamana. I live in Verona, city in Italy. I am head of software development in Forward Pro, and I love coding. I love ML.NET. I started to study this framework maybe 4 years ago. I'm very passionate about the world of ML, and I think that my session is very interesting because we go in deep to analyze the code aspects, and we will see some opportunities that we can take when we develop with this framework. So I think that is a very good session for the coding aspect about this framework.
So without further ado, I think it's time to get your presentation started. So I'm going to get your slides on and I'm going to give you the word.
Okay, thank you so much. Okay, let's start. And I tell you before, my name is Marco Zamana. I live in Verona, Italy. I'm head of software development in Forward Pro, and also I am MVP for the artificial intelligence category Microsoft. These are my contacts, my contact Twitter, my repo GitHub, and where you can find the code that you will see in this session. And this is my contact LinkedIn. So let's start with some concepts so we can understand all the concepts that I want to explain. So ML.NET is a cross-platform and open source framework. Is a framework that helps us to make a machine learning, to insert machine learning inside our .NET application or inside our application. There are a lot of products of Microsoft that including also ML.NET. Some of these are Power BI, are Windows Defender, and also is present in Azure. Why this framework is very powerful? Because it allows us to develop or train our model and infuse custom machine learning models in our application. Try to understand a legacy application that we have developed about 10 years ago. And we make this application with some framework that are not useful. So we try to understand how we can improve the scalability. We can improve the performance and improve the reuse of our code. we tried to explain if we want to apply some architecture, microservice architecture, or we wanted to separate our code for improve performance, improve resiliency, and also there we can pick up the opportunity to insert also the ML, because we have all the framework and all the tools that can help us to insert some model that can permit us to have some categorization, to apply some regression, or to do time series analysis, anomaly detection. So we have to think to ML.NET not only to a framework that can help us to insert ML machine learning in cloud application, but also in legacy application, so also in on-premises application. This is very important because we'll see after that the abstraction of the code is very important and can help us to insert this framework everywhere. So go on. And this image tells us build your own proven and extensible open source and developer focused. Is very important. We can use ML.NET with the most useful mode in the world, that is NuGet packages. ML.NET is a framework and these NuGet packages that we can include inside our application. We can include in a desktop application, in a console application, in a web app, in a Blazor web app, in a microservices app. This is important because the abstraction of the framework is very, very strong and is the tool that improves this framework a lot of. So another very, very important concept is that this framework you can apply ML.NET in 3 modes. The first is a simple API. So we can use the framework, we can develop the framework, and we can try to implement our iData view. We can try to implement to start to create our MLContext. We will see you after. And we know that it is supported also in .NET framework and also in .NET Core framework, .NET 5 now. Is supported in our OS, Windows, Linux, macOS, and we have also an hardware support. So it's important to understand that we can use in 3 modes. The first is a sample API, the second in a CLI, so we can install the packages, the package about ML.NET CLI, and we can use in a very useful mode after we will see. And we have also the model builder with Visual Studio that we'll see after also. Another aspect important is this box about the framework. iData view is one of the most important concepts inside ML.NET, because is the representation of our dataset in the pipeline of MLContext. We have trainers that are a simple API that can help us to make the training of our model. We have we have the transformers with the transforms, and we have also a package of AutoML. We'll see after. Another aspect very, very important is the extension, because the ML.NET can pick up a model trained by TensorFlow, and we can run with our framework. So we can include a model pre-trained, and we can use it as we want. There is a very interesting sample inside. I think is inside the sample of ML.NET, in where you can find the training about the cognitive services. So custom vision. I think that you know, and then we can use this model and import it inside our API. So we can use as you want. Yeah, we can include this model also in Azure Function, and we can use Azure Function to make a training of our model. We have a very improved mode to use this framework that is very simple, and the code help us after I see you. I told you ML components, transforms, trainer, the extension. We have API for build and train, and we have API for run any model. So we have very free to include our NuGet packages in our application and call our API in very simple mode. These API are exposed also for transforms, also from trainers, and also for extensions. In one session in Italy, I have prepared 1 year ago, and the use of image recognition, image detection, a real-time image detection with a model on an X. And we pick up the sample making VPF, and I make a version in Xamarin for simulate a mobile application. It's very useful. We can use everywhere. Now there is another concept that is the concept that the central concept of this session. As you know, we have in a machine learning experiment, we have 2 steps. The first step is the building, where we building a model. We trying to make some action for create a model that we can use after. So is before and after. Before we create a model, and for create a model, we have to collect, we have to load the data. We load data inside this iData view, that is an interface created by the team of ML.NET that pick up all the elements of our dataset. We create a pipeline, we train the model, and we try to improve the model. We need to understand that a model is never finished. No, there isn't a model that cannot improve. A model that cannot improve is a model that is die. Why this? Because our data continue to arrive to our application. Our application are aggregator of data. And so we have to work inside our application to pick up this data and improve our model with a life cycle of training. We have to improve the fitting our model and for make some evaluation, and for try to improve every day the accuracy of our model. The next step is the save model, because when we start this step, this pipeline, we try to arrive at the training of the model, and we can produce for the using. So the pipeline can go away with another step, but obviously it's like an asynchronous method inside an asynchronous method, our model must to improve everywhere. The step of the save model is the step in where we pick up this model and we give the access to our customer. So we can load the model everywhere and we can make a prediction to this model. It's very important because we understand that there are a lot of API that are very useful for our for us that we are developer, and we have a life cycle of this model, and we have a pipeline that is continuous. Another aspect that is important is the iTransformer object that is the object that is created when we load the model for make a prediction after. These are some aspects that maybe for the people that doesn't know ML.NET is difficult to understand. But when we will see the code, is very, very simple to understand these aspects. I am a basketball player. I was a basketball player some kilograms before. Allen Iverson was one of my preferred player, my best player. I think one of the best player of the world, and became famous in this interview where he took and he explained that we're talking about practice. So we're talking about coding. So let's see some feature, let's see some coding, and try to make clear some concept that I explained you before. A moment. So we start. Okay. I tell you before that there is three type or three mode to use ML.NET. The first mode is the CLI. For me, that I love CLI. I love also Unix Word, and it was a very, very good feature because it help us for make some classification runtime, and we can use this framework very, very fast and very, very useful. I make a sample. This is a PowerShell. I have a simple folder that is this CLI, a simple folder inside where I have inside this simple text file. We have a very simple sentiment analysis in this case. Obviously, is only to explain you the tool. We have this opportunity. We go to use ML.NET. We tell to this package to use the classification. We explain the data set. I make more big so we can see. Okay. The data set. We tell the position of the label column. So obviously start from 0, 1. We explain if the file has a header. In this case, it has a header, so it's true. And we insert the training time. The training time is a very cool feature because now I run. Is a feature that explain to the package that he have a 30 seconds for make a iteration on this model. In this particular feature, we are using AutoML because we make some iteration in the best in all the model for the classification that the framework has inside for find the best model. And at the end of the training, we have a classification where he explains us okay, sorry. Sorry, obviously the demo, ecco, okay. So he started to training, he make me a warning, and he makes some iteration inside our code for find the best model and also for create a scaffolding project that we can use to make some samples. In this GIF that I insert, you can see that we have the training, and at the end explain us what is the best algorithm that he find, and tell us what are the accuracy of the trainer. This is very useful because we can give us a direction of what we have to do with the dataset. It's obvious that there is, usually in Italy, we say that there is a maybe that is very, very big, because why I tell you this? Because AutoML is not the solver of our problem. It's an indicator. When I started to make a session about ML.NET, I say always there is two figures inside the world of machine learning: the data scientist and the developer. Data scientist is, for me, 80% of the work, because he have the responsibility about make the dataset, make a dataset clear, and find the best dataset to answer to his question. There isn't a problem in ML without the question. For example, I want to create a classification of sentiment analysis. The question is, this phrase or this sentence is positive or is negative? If you, another sample, if you go inside the sample of ML.NET, you'll find a sample of heart disease. I want to see you. Disease. No, sorry. Where is? Well, I see you from Visual Studio, that is better. Sample, sorry.
Hi, Marco.
So we're going to sample.
Sorry, if you wouldn't find the sample, we can link it in the YouTube YouTube description.
Yes. Okay. Okay. You will find heart disease prediction. I copy this inside. I think that you try. This is a sample that can answer to one problem. I make this sample. I was the person that I push this sample because I wanted to use a framework for try to make a classification starting about the heart disease dataset. So I search inside all the sites that have dataset something useful for make a response or for make an answer to my question. My question what was, but is possible that I have some disease or any disease with my heart property, with my heart attribute. So I find this sample that is very, very important to understand that it has a data set that was 73 column. It was very big, very, very big. For find this question, or for find the answer to my questions, from 73, we arrive to 14. And these are 40 columns. The age, the sex, the chest pain type, the resting blood pressure, serum, are all property that can help us to make a classification about our data. I have a heart disease, I have a pressure problem. So in this moment, I want to make this application. And for me, is the very best sample that can help us to understand that every problem, every ML problem has a question before. And this question must be clearly. Also, if we can we go to our customer to sell a ML project, we have to explain very, very clearly that the customer must to have a question, and this question must be clearly. This is very, very important because if the question is not clearly, the customer will pay a lot of money for no results, and it's not good. It's not good. Okay. So AutoML can help us, give us the direction, give us that that algorithm is good, can help us this algorithm, give us the best score for this algorithm, but a data scientist can help us to make some tuning about this trainer and can help us to improve the accuracy. If AutoML pick up 70% of accuracy, our data scientists can help us to arrive to 80. And this is the first application that we have. The second application is simple, and I see you here. Wait a moment, I open. Okay. Okay. This is the second application. We have a simple app, .NET 5, a simple app, an empty project .NET Core. We make head and we make machine learning. It open our ML.NET model builder in where we can select some scenario and we can upload our dataset for arrive to evaluation of our dataset, try to make some test. We make a test classification. Where we go training, we make a training in our data machine, and I go to select the same file before. As you can see, we have a data preview where we can explain us that we have two columns. We must to explain what are the label and how we can what are the input column. Why? You will see after that the ML.NET framework use a model input and model output. And we see after this abstraction that is very important for us. So again, we can go to training. We go to explain how many seconds we want of training. Make it 10 seconds. So we have a simple is a sample, a practice. And now you make iteration. It's like I see you before. Maybe I have a problem on this training. I think that this file is not very good.
Sorry to. When you stream, sometimes ML.NET takes a little bit longer. Just try to do a bit longer, like 30 seconds.
I tested before, but maybe don't tell me the same problem. I try with 50 and go on.
Yeah, try a little bit more. Sometimes the streaming takes a lot of your CPU away. At least
I try 90 seconds, and but I go on after we come back. So okay, thank you. Okay, and the sample is that you make a training, have a time to training. He make some evaluation in the code, and after he make us a little bit solution that inside have the all the API that we use for that we can use for our dataset and for our model. I want to until this go on. I want to explain. I want to show you another thing that is this. Okay. Maybe my machine. Okay. Well, the creation is a sample console application. When we use AutoML, our system create a simple application that is like this, a simple console application, where inside there are some explanation of our context. This is a sample. As you can see, we have the creation of this object that is MLContext. Now I stop this sample. We will pick up after. Why I stop? Because I want to go more in deep. So I go to the framework. This is ML.NET. This is the source, the repo of ML.NET. and we see all the packages. We have inside also the unit test. The unit tests are the most useful tool that we can use to understand this framework. Why I tell you this? Because inside the core we can see all the tests for all the methods that are inside the framework. One of important test is the aspect that when we see inside, we see the same code that we use when we make a training. A sample. If we go to the transform inference, for example, we see the importance of the dataset column, the importance of the data view type, the importance of another object. Now I want to see you if I find, I think that was this. Wait a moment. Ecco qua. Ok. Evaluate test. We have a input class. You see, new ML context. We have an input array. We have the use of this API and the testing of this API. One of the important aspects is that if you want to study this framework, you have to start from unit test. This start from unit test point is the key for understanding the life cycle of our model. Our model, as I tell you before, is one thing that is that we need to improve every day, every day. And the improve of this model start from understand the abstraction of this framework. So we see that we have a context. We see that we have this API, evaluate, load from enumerable, load from evaluate, are all API of our framework. I come back to the sample. So we have MLContext. What is MLContext? Go inside. Is our class that similar also with the also for the name is very similar to data context of entity framework. If we want to understand, is our perimeter, is the class that has inside all the API that permit us to use our algorithm for ML. So we have a binary classification catalog, a multi-classification catalog, and this catalog has inside all the trainers, all the calibrator, or the thing that we need to improve our model. Obviously, all these things help us to create a model with some parameters. Take a back. We have first a important step, that is training data view. A data view is an interface, and this like a database view. Is a place in where we make a loading of our text file on the base of type. So we have a load from text file of type T, okay? And we go to define inside the data view what kind the type of our dataset, if where is, so the path of our dataset, the header, the separator, the quoting, or the spares, okay? And these are all parameters of our framework that can help us to make our iData view, and we can, this iData view permit us to use all the process to train our model. MLContext help us to apply some transforms at our test. And there is a very, very cool feature that is inside the framework that is this append. This append help us to make some permit us to add some steps to our pipeline. Imagine if is a pipeline that starts with featureized text, and after we make append for improve our transformation. After, we can go to apply the trainer. We define the trainer. We make up we add inside some option like this. This is a trainer that derive of this type, as you can see, and we have also the option that are the option base that can be this frequency, the weight, the learning rate, the number of iterations, number of threads, and also there. Obviously, we can define inside our trainer step. As you can see, we use always our ML context. So we make a transformation, we make a trainer, and after we make some other append. We apply the estimator. Is important that when we finish to do this step, is important the evaluation. So the first step, it was to create our training pipeline, and it's okay. We have make a training, okay, but we have to also make evaluation. What is evaluation? Try to imagine that you have a data set about 10,000 of rows. You can train in the data set with 9,000 of rows and use other 1,000 for make evaluation of our model. You cannot make an evaluation of a model with the same data set that you have used for training. But you have to use another data set so you can evaluate your model very good. The next step, obviously, is to make a print of our of the matrix about the evaluation, and you can see the average of accuracy, you can see the deviation, you can see the confidence interval, you can see some metrics that can help you to understand if this model, if this algorithm is good, or you have to make some tuning to improve your model. And this is very, very good, very, very important feature. After the evaluation, you have to apply the training. Because you can make some evaluation, you can make a step back because the evaluation is not good. So you can apply this model with the training. And when you make a training, you make a sample fit. The fit is the method that can help you to apply the training of your data view. Yes, because you have a data view. The data view is in memory. And so you can fit it using the pipeline, because this pipeline is your estimator. After you have fit, the model is ready. If everything is okay, you arrive to save your model, and you arrive to put your model somewhere where you can maybe you can use for anything else, for example. So what you can see, you see the loading, you see the building the training pipeline with the creation of MLContext before, the transform, the trainers, the fitting, the evaluation. As you can see, when you do the evaluation, you call the MLContext, and you have some API that help you to make evaluation on the base of algorithm that you choose before. After, you can go to print the metrics, but is very useful. We have a abstraction. We need maybe we need another thing that we have two models. We have a model input and we have a model output. Model input, we had a file with two columns. One was a sentiment, the other was the label. The label obviously is important for training a model. But output, we have a prediction. So we have the if the sentiment is positive or negative, and we have the score, the proxy, the score of this sentence is positive. How is the accuracy of it about this sentence is positive? We have these two models. We have something that use these two models to make a prediction. You see, MLContext model create prediction, T input, T output. MLContext model load create. But if we have this abstraction, we can do another thing. If we can do another thing, make some try to understand what. We prepare our data, we make a build and train, we run, we pass dataset from preparing data and build and train. We pass ML model from build and train and run, and we use our model after the run. What are the next steps? The first step is a model creation. We have the tool. The second step is a then user application, because we pass to the next step that I tell you in the third slide, I think. So we have a process. We have a machine learning lifecycle that start to test, evaluate, pick up historic data, build and train, test, evaluate, pick up historic data, build and train, because our model never die. We create a model and we put the model for the consuming, because our customer must use. So we have this model in web app, in desktop app, in bots. I use ML.NET also in bots. If you use a bot framework or bot composer, you can include some API, or you can include something that permit you to use knowledge inside the bot. It's very, very cool. And the concept is that we have a lifecycle. So we are a dev. We have a lifecycle. Usually, we start to make a developer, and we start to collaborate to our project. So we have our repo, Azure DevOps or GitHub is the same. We have continuous integration, continuous delivery. So we have a build application, we have to test application, we have to release the application. We have our pipeline to our process, because we want that when we release we make the release of our project, we want to understand if our project is good. So we monitor in our app. We're going to understand if there is any problem or what else. Building, maintaining, and continuously updating the end user business application. Is iterative. We go, we go, we go. But there is another question. If we have ML, how ML go inside this life cycle? I see you before that we have a life cycle. How we can merge these life cycles? We can merge in this mode. We must extend our application lifecycle in the extended machine learning model lifecycle. So we have our application, we have to train in our model, we have to validate our model, we have to deploy our model, and we have to monitoring our model. Is another iteration, because our model, after we monitoring, we have to improve, we have to retrain with the other data set, and we have to improve this workflow continuously. We have the reproducibility of our model, the model validation, the model deployment, the model retraining. We are making a very good solution with this, but how we can do that is more simple than what we think, in the sense that we have a framework, we have an API, we are dev, and usually in my team, I tell to my developer that there is no code under that is not under unit testing. Unit testing is fundamental because it gives us the opportunity to add quality, to limit the regression, to limit the smart code, to limit the bad processes inside our developing lifecycle. And so we have also the unit test. What are unit tests? Are the elements that using our framework that has this good abstraction can help us to make a prediction engine. We have the MLContext, we have the create a prediction engine. We use the same model input and the same model output for have the same result prediction. And the cool thing is that we can do this as a bulk task. Try to understand. We have a model input, a prediction engine. We have a model input and model output. We pass a training model that is a loading, is a night transformer. We make a prediction. We have a result, and we can make an assert. Make an assert help us to make this, to make a text if a negative sentiment is okay, a text if positive sensitive is okay, could be a false positive. And also, we can block our deployment if our unit test doesn't have an accuracy that is better than 60% or 80%. This is fundamental because we can add quality in the process, and the framework help us to doesn't permit that our model go to the customer and it makes some bad prediction. Make some bad prediction if we are using ML.NET in an IoT context, for example, for making anomaly detection or for making predictive maintenance is a very problem if something inside the model is not good. So we can make a bulk evaluation of our model, and we can make an assert of greater or equal. How we can do that? Let's see. Try to make some changes. Try to make commit. and we push. We have a pipeline that is this. The pipeline is very simple. It's very simple. I want to see you before we go to the whoops. Obviously, we have a sample scalable web API in where we can is a sample API that can help us to try our model. What is this? I want to see your pipeline so we can understand how we do. If you see, is running now. I have, sorry, my browser, my PC is very slow. Okay. We see from there. I see also on a slide. I must log in inside. Okay. Okay. In my repo, you can find the code that I changed now. The pipeline is this. I make some a little big. We have a pool. Obviously, the pool could be Linux or could be Linux, some variables. And we have the script that is the build of the training console. If you remember, we have inside this application our training console. That is this. So, using pipeline, we can do some action that we can do normally with the .NET. We make the build of the model, we run the training of the model, and after we go to make some build test project and run a unit test. After we copy this model in another place, and another place is the web API, is an artifact created for web API, that the API, when start the delivery, in this moment, maybe I think that the delivery going to Azure is this. We have a delivery on Azure on the base of the artifacts created before. This can create an iteration, continuous iteration between our code, and we can make some model deploy in a very useful mode. This code you can find inside my repository GitHub, you can see. And we have the changes that I do before here, unit test. And this is a very, very useful sample for me to understand this important process. Another aspect of this process is that we have a model generation, we have training our model, we have test our model, we have a make evaluation of our model in double sense, because the model have make an evaluation in the first step when we make a training, and after when we make also unit test. So we have more step in where we make evaluation and testing, automatic deployment, and all these things can do with the sample console application make without ML with the CLI that I make before, and also in the class standard library. And these are step by step what we have to do. So I think that is I explained you before. The tasks are the step that we can build and compile our end user application. We can also run unit test, integration test, and after we can publish artifact. If you want to use container or Docker image, you can do. Obviously, the best context is the try to use container, because it's a very interesting mode to use. DevOps can help you in this. The approach is a simple YAML approach. I prefer YAML because a visual approach is not, for me, it was easy when I started to see the pipeline word, but after I use only YAML for is very, very useful. And so the step by step is the possibility to add quality. I have the last thing that I wanted to see you. I don't know if I try. I hope in that my computer want to help me. But maybe with the streaming, I think that is very, very okay. Another thing that I want to explain you is the use of .NET Interactive. If you don't know what is this tool, I suggest to you to go to understand what is. .NET Interactive can help us to use inside Visual Studio Code notebook, and we can use also ML.NET inside this notebook, and we can embed it also in other tools. My computer has decided to die, I think, for about 5 minutes, and okay. Okay, as you can see, we can use ML.NET notebook, ML.NET in notebook, very, very useful. We can go step by step. Don't be afraid by this. It was a sample application. .NET Interactive is a very, very good, very good tool that you can try, and you can send feedback to the team, or you can help the team with these important tools. Well, guys, I think that I've finished. So I want to thank you so much. I want to ask if there are some questions.
Hi, Micah. So we don't currently have any questions on YouTube, but yeah, I have used ML.NET quite extensively in the past, and it's nice to see a more holistic presentation. I saw that you did the ML.NET CLI, which is really good for automations and all of that stuff. And I like that you used unit tests.
It's very cool, the aspect of unit test, because it's the tool that we have our developer for improve our code. And in this method, for me, must give us the concept that the framework is very strong. Because I didn't find any other framework that has this abstraction that can help us to include in our workflow. There is no place that we cannot use this framework. We have the place of the application we can use, the place of the API we can use, the place of function we can use, and the place of unit test we can use. It gives us the opportunity to improve our quality so much, and the aspect of the dev for me is important.
Yeah, and one interesting thing is if you want to do the demo sometimes later, is you can try to do this in place WebAssembly and then host it on GitHub pages, and you essentially have zero cost machine learning on the website.
Yes. It's very cool.
Yeah, and I don't know if you heard about that. In .NET 6, there's going to be a major update for machine learning, ML.NET.
Yeah.
It's going to run on ARM, not just evaluation, what we have right now. I mean, evaluation, running, prediction, but also training.
Yes, for me, this aspect is I'm very I'm waiting for this. I'm waiting for this a lot of because there is I think that is a door open in a lot of things so that we can improve. And I want to tell one thing also to the person that to the viewers. And if you can help the team of ML.NET, help also with the documentation. Don't be afraid. There is obviously of everything project.NET is important to have the support, but ML.NET need your support also for the coding and also for the documentation.
On that note, they actually published on Twitter, they asked to help them out with some questions. Let me just quickly search for this. So they ask, I believe it's for explainability, to do a survey. I'm going to paste this into the chat. Let me just show you quickly this. So John Wood is someone who is... Oh, sorry, that wasn't the right one. This one, yeah. Sorry about that. This one is the right one.
Okay.
Yeah, so they trying to basically hear more about what they want for explainability and stuff like that. There's a tool called Neutron. If you have heard about it, you can open up the ML.NET model, and you can get some information. But the last time I tried it, it wasn't... A data scientist would probably understand it, but I didn't quite understand what was in it. So hopefully they're going to improve that.
I try to go in deep also for this concept, but I'm not prepared yet.
Yeah, but you know,
I try to make the survey, but in the middle I stopped because I think that I needed to prepare some concept because it was very deep in data scientist context, and it is a little bit outside of my zone. Understand?
Yeah, and hopefully what they're trying to do is that developers like ourselves would be able to look at the model and be able to explain to the clients, hey, this is how the decisions are made. Because, for instance, in your case, if the heart detection doesn't work well, people might be misdiagnosed, and misdiagnosis can have big consequences. And understanding how this works is quite important. It's kind of interesting. We're trying to remove the magic of machine learning by understanding what they have learned.
Well, I want to make you a sample. We try to make a proof of concept for our customer, and we use ML.NET to make some classification of the mail. It was a mailbox that it was a very full of mail. This mail must be dispatched to department 3 or 4 department. We make some classification for make a trigger that can help us to dispatch the mail automatically. But we make a proof of concept, so our model is not very strong. But we understand that it is very difficult to explain to customer the difficult to make a good model. Usually they come to you with 10 lines of data set and tell, okay, now you make me a machine learning. No.
Yeah.
There is also a concept in around ML that must to be clearly so much. And when I try to make a session, I explain always, I'm not a data scientist, I'm a dev, and I see you how to use .NET with ML.NET because it's very useful for these things. Okay.
And that's what I see with ML.NET. A lot of developers come in, they're not data scientists. And there's like two classes of machine learning. One is if it does it wrong, that's fine because there's at least one person verifying. So, nobody dies, nobody gets hurt in any way. It just takes a little bit longer for the person to fix the problem. But most of the time, it saves a lot of time. So it's all good. And there is, what we're trying to tackle more and more is the models, where if the model gets it wrong, there's real life impact, not just time-wise, but you actually impact people's life. And this is where explainability is very, very important and why there's so much focus, not to blindly trust something you don't completely understand.
Yes. I think that you tell good.
Yeah, well, let's slowly finish off. And just one note for anyone who was watching the ML.NET Model Builder UI. That also actually happened to me when I was presenting. And you don't actually know whether there's something wrong with ML.NET in that particular case, or is just that the stream is taking so much your CPU that it, instead of 10 seconds, now takes 2 minutes.
Well, I think that is a stream because I tried before the session because usually I have my thing that is prepared, but it success me maybe another thing another time now that I remember. I think that the problem is StreamYard.
Yeah, so
I have to make some. I wanted to try. In fact, you see that I have inserted also in the slide. I make a GIF in the slide because it happened me another time. Also, I don't remember if StreamYard or OBS. I think
WebEx is the
yes.
one that got it from 10 seconds to 3 minutes. So I know the pain. So in case anyone gets a similar problem, try to see if there's anything that takes a lot of CPU, or in some cases GPU, that can also cause some performance issues. We are doing machine learning in real time.
Yes, yes, yes.
You know,
But
if you use the Azure cloud, it takes 1 hour by default, not
well,
10 seconds.
it's difficult to make a session with these labs.
Yeah.
But it's okay.
All right. I think
Okay.
your talk was really awesome. I think it's a quite nice holistic view on it. And I hope we're going to see you sometimes in the future with more information, especially after .NET 6, where we're going to have it even on more
Yes.
places, ML.NET.
Yes.
And let's move on to finish the user group. I'm going to remove you. So the next user group is going to happen on 22nd of July. And we're going to announce guests and topics soon. If you want to submit your own talks, you can submit it on the GitHub. And we're going to add you to the list. Excuse me. And you're welcome to subscribe to our YouTube. Our playlist for the user group is growing. I think it's like 13 or 14 videos now. So we have quite a lot of videos now. And we would also be thankful if you can send us feedback for the user group so we can improve in the future. Or if you're just saying thumbs up to the presenter, please do that as well. And thank you, everyone, for the wonderful year that we had. This is, as you know, an anniversary for the user group, and I hope that we're going to have a nice another year. And also, thank you, Marco, for doing this wonderful talk. And I hope I'll see you next time. Thank you, and goodbye.